Hey, welcome to your deep dive. Today we're going deep into cybersecurity.
Ooh, exciting.
Yeah. And specifically how really smart deep learning models are being used
Yeah.
to fight back against DDoS attacks.
What's really cool about this is we're looking at a research paper that actually puts these models to the test.
Oh, wow.
They used a real-world DDoS attack data set, so
It's not all theoretical. It's like
it's action.
yeah, it's like in the trenches kind of.
Exactly.
Okay, well, before we get too far, can you remind me what a DDoS attack is?
Sure, imagine trying to load up like Netflix or Hulu,
Yeah.
but you can't connect. That's because like thousands, maybe even millions of bogus requests are just flooding the services servers,
Oh, wow.
creating this like huge digital traffic jam.
Ouch. Yeah, I can see how that'd be a problem for a business,
Yeah, absolutely. It's more than just like an inconvenience, right?
Right.
We're talking about like potential financial losses for companies,
Yeah.
service disruptions for users, and even damage to a company's reputation.
So it's not just a tech problem. It's like
Yeah.
something that could affect me.
Definitely could.
Okay.
And the thing is, these attacks are always evolving. Like attackers are always changing their tactics,
Well, just
which makes traditional defense methods less effective.
okay.
So think like low-rate attacks that fly under the radar,
Mm.
encrypted attacks that kind of wear these disguises,
Yeah.
and application layer attacks that really hone in on specific weaknesses.
So it's like they're trying to hit a moving target.
Yeah, that's a great way to put it.
Always changing. Wow.
It is, and that's where deep learning comes in. So these models, they can analyze tons of data and
Mhm.
spot those complex patterns without needing someone to like program in those patterns manually.
So it's like having a security guard that can learn on the job and adapt.
Yeah, exactly.
Wow. Deep learning to the rescue. Okay. Tell me, what kind of deep learning models are we talking about?
So this research focused on 7 different types:
7.
MLP, DNN, DCNN, LSTM, BIL-STM, CNN, LSTM, and DNNAE. Each model has its own strengths, making them suitable for different tasks.
Okay. Wow. 7. That's a lot to keep track of. Let's start with the one that really stood out in the paper, MLP. What made this model like the MVP?
So the MLP, or multi-layer perceptron, is like the foundation of a lot of these deep learning models. It's a network of interconnected nodes, each working like a tiny processor, analyzing data and passing on information. And in this research, the MLP achieved a really impressive 98.90% accuracy in detecting DDoS attacks.
Whoa, 98.90. That's amazing.
It's really good.
So how did they test these models?
They used a data set called CIC DDoS 2019,
Okay.
which is a big deal because it's full of examples of recent and diverse attacks.
Because they weren't just training the models on one type of attack.
Exactly. You need to show it all kinds.
Got it. So it's like a crash course in all different kinds of DDoS attacks.
Right. And they also split the data into training and testing sets.
Ah.
Think about studying for a test. You don't just want to memorize the answers. You want to be able to apply what you learned.
Ah, so they trained the models on one set of attacks and then tested them on a completely new set.
Exactly. That's how they were able to measure how well the models would perform in a real-world scenario.
Okay, so they trained them up, tested them out. What were the results?
The results were fantastic. All of the models achieved an accuracy over 98.69%.
Wow, they aced the test.
They did. This means that they were able to identify and classify DDoS attacks with a high degree of accuracy.
That's amazing.
It is. And that's super promising for potentially stopping these attacks before they can even cause any real damage.
That's great.
But there's one more thing I want to mention. They used a technique called smoten.
Smoten. Okay, that sounds kind of like a science fiction movie.
It does.
That.
It's a technique that helps balance the data set
Okay.
by creating synthetic data for attack types that weren't as common in the CIC DDoS 2019 dataset.
So it's like they gave the models extra training on the less common attacks so they wouldn't be caught off guard.
Exactly. And what's incredible is using Smoten actually boosted the performance of every single model.
Wow.
It helped them reach their full potential.
So Smoten is like a secret weapon for these deep learning heroes, huh?
Yeah, you could say that.
This is fascinating. So what's next? Where do we go from here?
Well, we've laid the groundwork now, understanding the threat of DDoS attacks and how deep learning can be used to combat them.
Yeah.
Now let's explore each of these models a little deeper and see what makes them tick.
Okay, let's dive into these deep learning models. We've got 7 in this cybersecurity game. I'm ready to meet the team.
All right, let's start with our MVP, the MLP. Remember, it stands for multi-layer perceptron.
Right.
It's like a classic type of neural network. To understand it, imagine a network of interconnected nodes.
Okay.
each processing information and passing it on to the next layer.
Okay.
The more layers, the deeper the network, and the more complex the patterns it can learn.
So is that why the MLP was so successful in the research?
Mm.
Because of the multiple layers?
Yeah, definitely a factor. Those multiple layers allow the MLP to pick up on subtle patterns in the data that like simpler models might miss.
Okay.
Think of it like this. If you're trying to understand a complicated story,
Yeah.
you wouldn't just read one sentence and think you know everything, right?
Right.
You need to consider the context, the different characters, the plot twists.
Yeah.
The MLP, with its multiple layers, can do the same thing with data. It builds up a richer understanding of what's going on.
Okay, that makes sense. So what about DNN? How is that different from MLP?
So DNN stands for Deep Neural Network.
Okay.
And it's essentially an MLP with a lot more hidden layers.
Oh,
So it's like taking the MLP and supercharging it.
gotcha.
The more layers you have, the more complex and abstract representations of the data the DNN can learn.
Okay.
And that's really helpful in cybersecurity because, the attacks are becoming increasingly sophisticated.
Right. So more layers, more learning power. Got it. Now, let's talk about DCNN. That stands for Deep Convolutional Neural Network. Sounds kind of intimidating, but I'm ready to conquer this beast.
They might sound intimidating, but they're actually pretty cool.
Okay.
They were originally designed for image recognition, but they've proven to be super versatile. Remember how I said the MLP works like a network of interconnected nodes?
Yeah.
Well, in a DCNN, those nodes are arranged in a way that mimics the human visual system.
So it's like they can see patterns in data just like we see patterns in images.
Exactly. They use these special filters called convolutional layers that scan the data,
Okay.
looking for specific features or patterns.
Mm-hmm.
And in cybersecurity, those features might be things like unusual spikes in traffic, strange packet sequences, or suspicious source IP addresses.
Okay, so they're like the detectives of the cybersecurity world, just meticulously analyzing the data for any signs of trouble.
I like that analogy.
Thanks.
Now, let's shift gears a bit and talk about LSTMs, which stands for Long Short-Term Memory Networks. What makes them unique is their ability to analyze sequential data, which is data that's ordered in time, like a timeline of events.
So this is where the memory part comes in.
Exactly.
Right.
LSTMs have this special type of memory cell that can remember information from previous time steps. Imagine you're reading a mystery novel. You need to remember what happened in the previous chapters to understand the clues and figure out who the killer is.
Right.
LSTMs do the same thing with data, allowing them to analyze the sequence of events leading up to a DDoS attack.
Oh, that's fascinating. It's like they can connect the dots and see how the attack unfolded over time.
Exactly. And that's why they're so powerful for detecting DDoS attacks,
Okay.
which often involve a series of steps or stages.
So LSTMs are like the historians of deep learning, like they're piecing together the past to understand the present.
Yeah, I like that.
Okay, so what about BILSTMs? How are they different?
BILSTM stands for bidirectional LSTM,
Okay.
and it's essentially two LSTMs working together. One LSTM reads the data forwards in time, while the other reads it backwards. This way, the model gets a more complete picture of the temporal context.
So it's like having two historians, one reading the history books from beginning to end and the other reading them in reverse.
Yeah. Okay.
Now, let's talk about CNN LSTM, which, as the name suggests, is a hybrid model that combines the strengths of both CNNs and LSTMs.
Wow, that sounds powerful.
It is. It's like having the pattern recognition skills of a CNN and the memory power of an LSTM all rolled into one.
So it's like the ultimate cybersecurity multitasker.
You could say that.
Okay.
So CNN LSTM models can extract spatial features from the data using their convolutional layers and then analyze the temporal relationships between those features using their LSTM layers.
Okay.
This makes them really well suited for detecting complex DDoS attacks that might involve both spatial and temporal patterns.
Wow, that's really cool. Okay, and lastly, we have DNN AE. What's the AE part stand for?
AE stands for autoencoder.
Okay.
It's a special type of neural network that learns to reconstruct its input.
Hmm.
Imagine you have a photocopier that not only copies a document, but also learns to compress the information into a smaller file and then decompress it back to the original.
Okay.
That's essentially what an autoencoder does with data.
So is it a digital zip file?
Exactly.
Okay.
The interesting thing is, during this compression and decompression process,
Yeah.
the autoencoder learns to identify the most important features of the data.
Okay, I think I'm starting to see where you're going with this. So in the context of DDoS attack detection,
Yeah.
the DNNAE would use the autoencoder to extract the most relevant features of network traffic and then feed those features to a deep neural network to decide whether it's an attack or not.
Precisely.
Wow.
This approach can be particularly effective for detecting attacks that involve subtle deviations from normal network behavior.
Okay.
It's like having a security guard
Mm.
who's trained to spot even the smallest signs of suspicious activity. This is incredible. It's amazing to think that we can train machines to be so observant and vigilant. But I have to ask, what are the limitations of these models? Are there any downsides to using deep learning for cybersecurity?
That's a great question. While deep learning offers a lot of promise for cybersecurity, it's not a silver bullet.
Right.
One of the challenges is that these models require a lot of data to train effectively.
So it's like the more examples you give them, the better they'll be at spotting attacks.
Exactly. But getting access to high-quality, real-world data can be tricky.
Okay, that makes sense. What about the attackers? Won't they try to outsmart these models?
Absolutely. It's a constant arms race, you know?
Yeah.
As defenders develop more sophisticated tools, attackers will inevitably find new ways to bypass them.
Oh, geez.
They might try to poison the training data, for example,
Oh, wow.
or craft attacks that specifically target the weaknesses of the models.
So it's like a game of chess where both sides are constantly trying to outmaneuver each other.
Exactly, and that's what makes cybersecurity so fascinating. It's a dynamic field that demands constant innovation and adaptation.
All right, so we've got our deep learning heroes, but we also need to be aware of their limitations and the fact that the bad guys aren't going to just sit back and watch. What's next on this deep dive?
Well, we've covered the present. Now let's take a peek into the future.
Ooh.
The research we discussed today focused on detecting attacks as they're happening.
Right.
But what if we could predict attacks before they even occur?
Whoa, that's like having a cybersecurity crystal ball. Tell me more. This sounds fascinating.
Yeah, it might sound like science fiction, but predicting cyber attacks, particularly DDoS attacks, it's becoming a reality. And it all comes down to recognizing patterns. Even though attackers are evolving, their actions often leave like these subtle clues,
Okay.
like
yeah.
shifts in network traffic patterns,
Right.
attempts to probe for weaknesses, or even chatter on the dark web.
So it's like a detective noticing a suspect casing a joint before a robbery.
Exactly.
Yeah.
Like those little details that seem insignificant on their own. Yeah.
But together paint a bigger picture.
Right.
Deep learning models can be trained to spot these subtle signs, raising a red flag before an attack is launched.
So it's like an early warning system.
Yeah, imagine getting an alert saying, hey, we're seeing some suspicious activity. Looks like a DDoS attack is brewing. You might want to reinforce your defenses.
That would be amazing. No more scrambling to react after the damage is done.
Right.
We could be proactive.
Exactly.
Stay a step ahead. But wouldn't the attackers catch on to this and try to mask their activities?
Of course they would. It's like that chess game we talked about.
Right.
As we get better at predicting their moves, they'll find new ways to disguise their intentions.
Right.
Or develop attacks that are harder to anticipate.
So this whole cybersecurity landscape is constantly evolving.
It is.
It's a never-ending battle of wits.
That's right. And that's why it's so crucial for researchers and security professionals to stay ahead of the curve.
Yeah. We need to be constantly learning, experimenting, pushing the boundaries of what's possible with deep learning and other technologies.
It's reassuring to know that, brilliant minds are working on this. So after this deep dive into the world of DDoS attacks and deep learning, what's the key takeaway you want our listener to walk away with?
I'd say the biggest takeaway is that deep learning is transforming cybersecurity.
Yeah.
Particularly in the fight against DDoS attacks.
Right.
The technology is still evolving, but it has the potential to revolutionize how we defend ourselves in the digital world.
And for those who might feel a little overwhelmed by all this technical stuff, what's the most important thing to remember?
Don't be afraid to explore and ask questions.
Yeah.
Cybersecurity is a vast and ever-changing field, but there are so many resources available to help you learn and stay informed.
That's great advice.
Eh.
Well, thanks for taking us on this incredible journey into the world of deep learning and cybersecurity.
My pleasure.
And to our listener, thanks for joining us on this deep dive. Remember, in the world of cybersecurity, knowledge is power. Stay curious, stay informed, and stay safe out there.